All right, number two. So again, it's intercepts and asymptotes. So my intercepts. Let's start with my y-intercept. That's the easier one. So plug in 0. 0, 0. You're left with 5/4, 1.25. Let's go ahead and plot that. So 1, 2, so somewhere about right there. All right, x-intercepts. So set it equal to 0. And as I stated on the previous one, after the first step, this is going to cancel. So you'll be left with the numerator equal to 0. 5 is never 0. There's nothing you can plug in for x to get 0 for an answer. So there is no x-intercept. Okay, asymptotes. Let's do horizontal one first, if it has one. The degree of your denominator is 2. Degree of your numerator is 0. So the degree of your denominator is larger. So let's go back to the other screen to look at our individual cases. So the degree is the bottom heavy. Degree of the denominator is larger. In that case, y equal to 0 is the horizontal asymptote. So as x gets really, really large, the y coordinates get closer and closer to 0. Similarly, on the other side, as x gets really small, negative a billion, and so forth. Will it cross the horizontal asymptote? Well, again, if you set it equal to it and try to solve it, that is, you solve for x, that'll tell you when it crosses it. As we already determined, this is never equal to 0, so it'll never cross it. Vertical asymptotes. So we need to find out when the bottom is equal to 0. So we have this, set it equal to 0, and solve it. Factor it if you can since it's quadratic, or do quadratic formula to solve that equation. This one's going to factor nicely. X minus 2 minus 2. So when x is positive 2, so we put positive 2 there, you'll get 0. So the bottom is 0 when x is equal to 2. All right, so let's go ahead and draw that asymptote. I showed you the other one as well, but come back to it. So vertical asymptote at x equal to 2. Horizontal asymptote at y equal to 0. These are equations. Do not just put 0 and 2. You need the equation y equal to 0 and x equal to 2. All right. Let's get a few more points to help guide us as we do our graph. Point to your choice. Pick whatever you wish. Again, though, I would recommend picking numbers around your vertical asymptote, which is 2. So let's plug in 1. Let's plug in 3. And do some calculating. So plug in 1. What do we get? Plug in 1 here and here. It's a bit easier. Negative 1 is 1, so we get 5. So plug in 1, you get 5. So that's 2, 3, 5. Oops, wrong this side. Plug in 3. So put 3 there, 1 times 1. You're going to get 5 as well. So over here, it's also going up. So this one approaches the asymptote upward. If you plug in very small numbers, negative 100, negative a billion, and so forth, you'll get y coordinates closer to 0. On this other side, it's also approaching the asymptote in the same direction upward. More points if you wish to see what's happening along the way. So what's happening here is this is x minus 2 squared. when you have a factor with even multiplicity for the vertical asymptote, that will lead the graph to approach it in the same direction. In this case, they're both going up. They were not going in opposite directions, as was the case here, where one went up, one went down. So when it's even, an even power, they go in the same direction. And that's what this states over here on that t squared part. They'll come together in the same direction if you have an even multiplicity. But if you make a table, pick some values, you would see what's occurring. So that's number 2. All right, number 3. So same process, intercepts. Extend this out. Oh, what am I doing? Intercepts. So let's do y-intercept first. So let's plug in 0. So 0, 0, you're left with negative 3 halves. Oh, so negative 3 halves. So there's my y-intercept. Negative 1, negative 2, so somewhere right there. X-intercept. So let's set this guy equal to 0 and see when that happens. And the shortcut again, because it's just going to cancel after step 1, is when is the numerator equal to 0? All right, and the numerator is equal to 0 when x is 3. So there's our x-intercept. It's going to cross the x-axis at positive 3. 1, 2, 3. Let's put it right there. All right, asymptotes. So horizontal asymptote, let's do that one real quick. It's going to be at the line y equal to 1. It's where the numerator has a degree of 1, the denominator has a degree of 1. When they have the same degree, you take the ratio of the leading coefficients. So 1 over 1, which is just 1. So horizontal asymptote at the line y equal to 1. Going over here. Clean this up just a little bit. All right, vertical asymptotes. That's when your denominator is equal to 0. That occurs when x is negative 2. And that's also the equation for that. So 1, 2. So there it is. There's no holes in the graph. Again, if x plus 2 was a factor up top and it canceled, then when x is negative 2, it'd be a hole in the graph. You'd have to plug in and find the y coordinate. So a few more steps there. But there are no holes in the graph in this case. And again, there won't be any on this assignment. Okay. From here, it's your choice. Make the table of values if you wish. This is going to go this way and then go this way. On the other side, are they going to go in opposite directions or the same direction? Well, we can tell right away because the multiplicity is odd, so they're going to go in opposite directions. If you want more confirmation of that, pick some x's that are on this side of your vertical asymptote. Let's plug in negative 3. We'll get negative 6 over negative 1, which is 6. So 2, 3, 4, 5, 6. So we'd be up here somewhere. Pick more points if you're choosing. So you get further away, it'll get closer and closer to 1. Will it cross it? Let's check real quick. It's not. I don't think we're going to have any on this assignment where it does cross it. But to determine that, you would take the value that you have for your horizontal asymptote, set it equal to it, and solve for x. If you can solve for x, that is where it crosses it. So let's do that here. Multiply both sides by x plus 2. So let me go and write that out real quick. times x plus 2, x plus 2, that cancels. All right. As we go further, minus x, you get negative 3 is equal to 2, which is not true. Negative 3 is not equal to 2. Our assumption of the original function being equal to 1 is false, so it'll never cross it. All right, so let me clear this out. So number 3 is done. There's nothing more to do. Unless you want more points, fill out the table with the values of your choosing.